Hi, I'm Dave Soriano. I'm a chemistry professor with the University of Pittsburgh's Bradford campus in northwestern Pennsylvania, USA. Just a very brief demo of a Zinc-air battery. They're used in hearing aids, of course, and researchers are looking at other applications. And I believe this is the first functional Zinc-air battery. I'm using glass wool with a sheet of zinc that was recovered from a 6-volt ever-ready lantern battery, and I've used fresh sheet metal zinc, and you can see the voltage there right now. I'm pulling about 0.83 volts. I'm running air through, so let's see if we can move this over to give you an idea of what's going on. And what we're doing is passing air through a Becton Dickinson 30 milliliter tube, which I cut down to size, and I have it in there, the sheet of zinc wrapped in felt, a felt-like material, very commonly used to wrap bottles, chemical bottles. It's a pinkish color, works very well. There's perforations in it. And I'm passing air through it, so the zinc wool, the steel wool wrapped around the felt is coming in contact, of course, with air to reduce it down eventually to couple to the zinc to form zinc oxide. Now, what's unusual about this is that instead of using potassium hydroxide in solution, sodium hydroxide in water, I'm using, or acetic acid with sodium chloride as electrolyte, I'm using an ionic liquid. And the ionic liquid that I'm using is a carefully prepared molar ratio of the choline chloride to urea. The ionic liquid, this particular one, appears in the United States patent and will not freeze until it hits about 11 degrees Celsius. So our area of research really is to make these little inexpensive prototypes. So you can get you a side view, a top view. There's the syringe. I'll take it apart in a minute. Got the electrodes hooked up with the air passing through them up to 0.84 volts. And our research is finding the best non-toxic ionic liquids that will perform at temperatures well below 0 Celsius. And the first one we tested was choline chloride and urea. And of course zinc oxide is put in baby powder. So the Zinc-air battery is about as safe as you could possibly get. So the novelty is to test out various ionic liquids that A, are non-toxic, B, will stay liquid at reasonably cold temperatures, and C, won't leak or evaporate. And what we will do in the future is drill some mini holes in the surface of the tube so we can get plenty good aeration. Now, another thing that I'm working on, which I won't show you in this video, but another application is we will use solar panels in our greenhouse to charge up 12-volt batteries, electrolyze water, separate the gases, let's say with a Brownlee type apparatus, use the hydrogen as a fuel or in catalytic reductions, but then to take the oxygen and pass it through the zinc battery, steel wool battery, and use that oxygen from water electrolysis to carry out the reduction on the steel wool surface. Let's check the amperage. Now, before, what did I get? I got about 162 milliamps, so let me see what we get now. So I'll bring this down to okay, it's varying, but I think you saw a 162 there, and you can see the current is dropping, and but it was a pretty hefty start for a little prototype, and we'll be working steadily on this to improve it, and we'll have updates to YouTube. But we wanted to demonstrate the feasibility of an ionic liquid. And of course, we want to make sure the the steel wool is not coming in contact with that zinc. So I think we're going to doubly wrap the zinc so the steel wool is not in contact. If you want to get a hold of me, Soriano, S-O-R-I-A-N-O, Soriano at pit.edu. Hey, thanks for watching. Bye now.